resistance of a wire. Okay, factors that affect a resistance of a wire. Is it first time you learn? No, it's not the first time you learn. It is the second time you learn. First time you learn in Form 2, Chapter 7. Now, my student, I don't know how many of you remember. Some of you follow me since Form 2. I don't know how many of you remember. Form 2, Chapter 7, we had one formula. Dowlat. 4 factors. Don't know how many of you remember. Dowlat. Actually, not D2, only one D. Not 2D, one D only. Dowlat. Okay. 4 factors. First factor, diameter of a wire. Nowadays, you're calling what? Cross-sectional area of a wire. Okay. Diameter lah. Means, is the wire, is the conductor thick or not? Right? We are talking about what? Factors that affect resistance. Resistance. How does it increase and decrease the resistance? Okay. Diameter of conductor. Means the wire. Tebal ke dia halus? Tebal, like what? Like the one outside there. Electric cable from TNB. Halus means what? Like your USB cable. The one halus. Okay. Next one. L. Length of conductor. Wire. Long wire or short wire? Longer wire, like National Grid Network. Okay. Short wire, like the one you use for power bank, charging your phone. Short wire. Okay, next one. T got 2. Number 1. Type of material. Okay, jenis bahan. Type of material. What do you call it nowadays? You call it as resistivity. What is the difference between the word resistance, okay, and the word resistivity? What is the difference? Resistivity is fixed. It is fixed to a material. Okay, copper, aluminium, irons, and lead, tin, zinc. They are fixed. Every conductor has a fixed resistivity. There is a value, there is a unit for us to know what is the resistivity of the material. Okay, so depending on what you are trying to do with the wire, you will use different material to make it. Okay. T equals 2, another T. What T? Temperature. Temperature of conductor. Teacher, how is it that temperature is affected? I mean, how does temperature affect God? Wire under the hot sun. Wire which is underwater cable. Wire which is in an electronic device which is burning hot. Now, you may not know, students, but electronic parts can go up to very high temperature. Yes. Easily, 100 degrees, no problem. Your computer, your processor, capable of going up to that temperature. Factory, industrial machine, even more capable of going up to that temperature. Okay. So definitely, these are the 4 factors which affect the resistance of a conductor. Okay. But question is, what is the relationship? So what you're going to learn in Form 4, okay, Form 5, which is different. Form 5, you are going to learn, all right, relationship and a little bit of calculation. Okay. So first one, okay, diameter of conductor. Talking about what? The cross-sectional area. Wire big or wire small? That means if you today you cut the wire, you see. Cross-sectional means you cut the wire, you see. Wire big or wire small? Okay. So big one means high diameter. This one low diameter. Relationship is what? Relationship is the greater the diameter, the lower the resistance. The lower the diameter, the greater the resistance. In other words, diameter, or you can call it as cross-sectional area, okay, is inversely proportional to resistance. Okay, level up now, yeah, from 5 students. All right. So, what is the story? Okay, you see, inside a wire, there are a lot of things that are trying to block the electricity. Okay, let me just zoom in this picture so you can see clearly. I draw for you. Okay, in the wire, okay, because it is the same, let's say lah, okay, same type of wire, because we are doing experiment, constant variable type of material. Okay. Let's say both of these are copper wire. So copper wire itself naturally has got some resistivity inside, right? There are some things that are trying to block the electricity. So I will use red color to represent. Okay? This is trying to block the electricity. Now we be fair, right? Because it's the same material, resistivity, we draw the same. Fair? Okay. Now, imagine now you are trying to walk through this tunnel. Imagine now you are trying to walk through this tunnel. I ask you, left side, right side, which one to go through? Which one easier for you to climb through this tunnel? The red color things are trying to block you. Yang ni halangan untuk kita. Trying to block you. Trying to block you. You are trying to climb through a tunnel. You can imagine these red color things like rocks lah or glaciers lah or whatever. Which one is easier to climb through? Icicles, not glaciers, icicles. Which is to go through? Of course, left side easier to go through. Agree? Why? Because you have got more empty space. Correct. If let's say today you want to walk through the tunnel, correct, it's easier to walk through. There is many empty space for you to walk through. But here, oh, little bit you are already blocked. You see now. So left side is easier for the electricity to climb through because the diameter is big. A lot of empty spaces that the electricity can pass through. Okay. Nothing has changed. Resistivity is still there, it's still copper, but diameter big, easy to pass through. So that's why usually big cable, underwater cable, okay, electric cable outside, national grid network cable, very, very big diameter, very thick, because of this reason. Okay, diameter of conductor lah. Okay, cannot you stop me. Okay, next one, length of conductor. Length of conductor. Relationship. The greater the length, the greater the resistance. Right? Smaller the length, or the shorter the length, the smaller the resistance. In other words, length is directly proportional to resistance. Right? How to say? Oh, you can imagine it is Harisukan. All this I teach from Form 2. Harisukan. Harisukan. I ask you, is it easier for you to run 100 meters, or is it easier for you to run 400 meters? 100 meter ke 400 meter lebih senang? Of course, 100 meters. Okay, for a person who never go to Harisukan, okay, for a person that never participate in Harisukan, of course, 100 is easier. 400 man, 400 easier. Okay, since when is running 400 easier than running 100? Let's not talk about too detailed one lah, about running dynamics lah, competitiveness lah. No, let's talk about pure distance lah. Which one is easier? I know you are trying to say that, teacher, 100 meter be difficult, no, because you must know, you must have this method of impulse running lah, must pursuit, and all that lah. Simple. 100 meter easier lah. Easy to run lah. 400 meter, if you ask people like me go and run 4 meters already problem lah, 400 meters. Nonsense. Okay. So anyway, sorry. So 100 meters easy to run. So same goes to this wire. Okay? Today, if I have a very long cable, 4-meter cable, of course, electricity from point A to point B. Remember, you have learned previously already. How does electricity travel? Potential difference. Potential difference is equal to the work done. The work done to push a charge from point A to point B. Right? So if your point A and point B is further away, it makes it more difficult for this electric charge to travel. Hence, make it difficult for the electricity to go through. Okay? So resistance become high. So length, your cable is long, resistance will be high. Okay. Then from here, you can actually talk a little bit about K-bar already. When you have long cable, high resistance, where is the K-bar the problem? Problem is with what? Resistance, you all must know. is actually a change in energy. Because resistance, you are trying to stop the electricity from going through. So the force that you stop must be converted into another energy so that we obey the principle of conservation of energy. You cannot say, today I try and block the electrical energy, but then, hey, just disappear this energy. No. What happened to the electrical energy? It's being converted into heat energy. That's why wire, which is high resistance, it get hot very quickly. For example, tungsten in the Thomas Edison bulb. Hey, metal coil in your oven. All those are because of high resistance. And that one because they use a high resistivity material. The oven purposely we want to make the metal coil hot now. Kan? So resistance is going to turn to heat energy. Wasting electrical energy, providing heat energy to the surrounding, both are disadvantages of high resistance. So in an ideal world, what we want to do, we want to minimize resistance as much as possible. So this is also one of the kebat problems with what National Grid Network. Rangkaian bekalan elektrik di Malaysia. Because electricity takes a very long distance to travel. Electricity that people in Selangor use may very well be from Johor. Not joking, seriously. Last time when Johor had power outage, our power cut also means that a portion of our electricity came from Johor. Remember there was one day, tiba-tiba the electricity just gone, blackout, and die afternoon. That one because of Johor got problem. Johor got problem, we got problem. Because connected. So imagine we got to travel such a long distance. What happened? Now the wire need to use other method to overcome the heat energy. Okay? Sebab jarak yang dia lalui dah jarak yang besar ataupun yang jauh. Jadi dia kena atasi masalah ini dengan apa? Dia kena guna bahan yang kurang resistivity and diameter has got to be big. That's why the cable outside is very big diameter. If they could use a small one, why not? Small one save money. You think copper is cheap? Save one, small one save money. But cannot. If they use small one and then added some more, the length is already so long, the wire easily burn up. So cannot. Because the length is already very long, National Grid, they must reduce it. I mean, they must minimize the problem by making the diameter as big as possible. Then of course, you also learn in Form 3. Transformer. Transformer help us to overcome a part of the problem. How does transformer help us? We step up the voltage. When we step up the voltage, you force the resistance to drop. So, we are going to preserve as much electrical energy as possible. Kalau tak, apa jadi? Dalam perjalanan ke sini, tenaga elektrik ini ditukarkan kepada tenaga haba. Wayar semua panas, tapi rumah tak ada api. Agree? So, you see, now you see everything is connected into a big story. From Form 2, you learn about this Daulat. From Form 3, you learn about, transformer. And then from here, you learn about Ohm's law in more detail. Everything makes sense. Agree? Okay? So, length of conductor. Remember, Harisukan story. Okay. Now, temperature of conductor. Also, Harisukan story. How to say that? Okay. Relationship first. The greater the temperature, the greater the resistance. The lower the temperature, the lower the resistance. Temperature is directly proportional to resistance. How to say? Harisukan story. Is it easier? Of course, you must fix the distance. When you are comparing one variable, one factor, other factor must become the constant variable. Others must become constant variable. So now, we fix a distance. 400 meters. I ask you, is it easier for us to run 400 meters under the hot sun or easier to run 400 meters on a cloudy day? This one I don't know what kind of nonsense story coming again. Somebody will definitely answer one. This is easier to run on a hot day because the hot day will make us a little bit angrier and I don't know what kind of nonsense you will come up with. No, cloudy. Okay, this time normal. Cloudy. Exactly. Easier for us to run when it is cloudy. Why? Because the temperature is cooling. Agree or not? Your body already so hot, no? Some more the hot sun giving you the temperature. Of course, you will feel a bit stuffy and a bit tired, lah. But cloudy and windy means okay, relax. So that is the story here, lah. If the wire is very hot, the resistance will increase. That's why people, that's why you focus on spending so much money on a cooling system in everything that you have. How many here is a PC geeks? PC, building PC one. Wow, people can spend a lot of money on a fan, cooling system, thermal paste, heat sink, y'all know heat sink, thermal paste, inside the computer, there is a copper pipe lah, the heat sink lah, and the graphics card there lah, processor there lah. Okay. Why? Because your components inside can get very hot. For example, your processors inside without the help of thermal paste and fan, okay, it will actually go up to high temperature, 80 ke 100 So actually having the fan helps it to cool down so that it can be under good working condition, 30 degrees, 40 degrees, and so on. Even nowadays got what, using water cooling system water. Seriously, you ever see people they refill water into the computer. The water, cold water is running inside to cool down the system. Seriously, not cheap on the system. Must give water every day to the PC. Because the water will evaporate. So they give water every day. Like watering the plants like that. Got water cooling system. Because what? Because the PC is very hot. When the PC is hot, your computer will jam. So you realize or not? Why your computer jam when it's very hot? You of course you are doing something that make it hot lah. That's the first thing lah. You are playing game ke apa, you make it very hot. You make it very hot, then it become jam. They become jam, you complain. But you are the one who make it hot in the first place. Okay. So what is the solution? You must buy computer which has a good ventilation system. That's why you see a computer, a PC is actually built with a lot of wind. I mean, there's a lot of focus on the wind. How does the wind flow? There must be an outlet for the cool wind to come in, and they must have a cool hot air to go out. That's how most of the PC design. You see your phone, you see your PC now, you pick up your PC and see. You put a tissue paper there, you try and see. Definitely, one air go in, one air come out. It's a good system. Okay, you see the PC, gaming PC, they install 3 fan, not enough, 6 fan. The bottom also got 12 fan. Why? Because they want to maximize the wind circulation so that it can cool down the whole system. One more application in real life. Bitcoin mining. You know Bitcoin mining? Young people, you know Bitcoin mining? Using a PC to complete Bitcoin transaction to get Bitcoin as commission. Don't know. So I'm younger than you all or what? I thought this is young people stuff. No. No, don't know. There's this one job you can do. Okay, which is Bitcoin mining. Bitcoin is a cryptocurrency. It is using the blockchain technology to complete transaction. Normally, when we use normal money, right, to transfer to people using Do It Now, we go through the central bank. Correct? We go through the bank will help us to transfer the money. Correct? Yeah. It's not take our money straight away put to the bank to the person you want to transfer to. They take your bank, they take the money, they give to that person. Do it now lah. That one is normal money lah. Bitcoin, cryptocurrency, they take the money. No one take. The money straight away sent to the person. That's the difference. Do It Now, the bank take first. Bank take first, the bank give. Cryptocurrency, why is so good? Because decentralized. No one control. Money straight away sent to the person. But then must have people to help. So this is when the Bitcoin miners will help. Because to complete this transaction, need a lot of computer calculation. So that is when this Bitcoin miner, they will have a big system to help complete the mathematical calculation. This is to complete the transaction for them. Okay, so they will help lah. These people will help lah. They won't take your money. The money won't go to them. They just help only. They help to complete the transaction to go through. Then in the process, since they help you, you will pay fees, transfer fees. These transfer fees become their commission. Okay, so they take a little bit of your fees for helping you to send the money to other people. Okay, so this is the world of cryptocurrency. To help people calculate the computer calculations, they need a very big PC or machine to calculate. This machine, because they are doing so much of calculation, it gets very, very hot. So how do these Bitcoin people, they actually cool down this PC is by putting them in an aircon room. So people who do this industry, they actually have a room which is specially created for this system. It's a PC basically, but in an aircon room. They turn on the aircon, they blast the aircon so that the aircon will help it to cool down the system. Otherwise, if every time it's making the calculations, it will blow, it will burn up very easily. So they must put it in the aircon system, aircon room. That's the reason why most of the technicians' room actually is cold one. Today, if you go to any big company, bank, their data system, computer, IT, the IT room is actually cold one, very, very cold. It is the coldest room in the building. Why? Because they must protect the computer. If they are in a room which the computer get hot, but there is no circulation and then it's very hot, the surrounding, the computer would eventually blow up. Because of this, increase temperature, increase the resistance. All right, resistance create heat blow up the computer. So that's why they must have aircon room. Can understand? Am I talking to myself? Am I going too far? You understand? I'm sharing with you young people things. Okay. Go and figure out more. This is your world. This is your world. Seriously. If you are not into all this, you must at least. I'm not into it, but you have got to at least know about it. This is your world. Yeah. In the future, this is what we're talking about. They are skeptics. Some people don't believe about crypto or this sort of technology. Very old school people. But there are also large pockets of people that think this is the future. That fella, Mark Zuckerberg, big supporter. So don't worry, you have a big supporter behind you. Young people. And there are some people, old school investor don't believe. Mark Zuckerberg believe. He's a technology guy, so he believes. See who wins this war. Okay. See, in the future, you still need to hold paper money. Maybe your children time no more paper money. Okay. Last one, resistivity. Okay. Resistivity. It is directly proportional to the resistance. Okay. Higher resistivity, okay, which we actually use rho, okay, to represent this symbol. Use blue color. What happened? Sorry, use wrong one. Higher resistivity, higher resistance. Lower resistivity, lower resistance. So resistivity is directly inversely proportional to resistance. Okay, how to know resistivity? No choice, must Google. Because this thing, like I said, is fixed one. There. Okay, resistivity is fixed. So this one, they are calculating for you. Ohm, centimeter. Ohm, centimeter. That means for every centimeter, okay, the resistivity 0.034 times 10 power negative 5 ohm. Like that, like you read. Okay. So what I'm saying is there is a list. There is a list. There is a list of the resistivity. So of course, over here, you can see clearly why we use copper as material for wire. Most of the things is copper. Your USB cable is copper. Outside there, electric one, copper. Why copper? it is the best material that you have. Teacher. Silver lower 1.59 times 10 power negative 10 power negative 8. Teacher, lower than copper. Teacher. The guy making our national grid a bit stupid. Teacher. Silver is a bit better. Let's propose. Let's propose. Let's propose in parliament. Let's change everything to silver. Can I, people? Who's the stupid fella? Where to find so much silver? Hey. Where to find so much silver, people? Huh? Copper easy to find, cheap. Silver, silver people used to wear one, not to make wire. Resistivity is one thing. Cost is another thing. Cost is another thing. Huh? Where to find that much silver? That's the first thing. Silver got how expensive is it? Where got time to make it into this wire? Agree? Yeah, of course, got other problems, such as the the thermal, the conductivity, the thermal resistance of it. How well it can survive. The melting point and all. Okay, that is another problem. Okay, the expansion constant ratio, a lot of problems. But basically, why we don't use silver? Expensive. Okay, and then the rest getting worse and worse lah. Last one, you are familiar lah, Constantin wire lah. That's why you use it for experiment lah. Can see effect very clearly. Can see effect very clearly. Okay, so Google. Okay, you can find. So this number that you all see, the bigger this number, the more resistant it is lah. Like the one just now, right? The copper one. Copper. Copper small number. Rho. This one we use rho. This one is rho. Resistivity rho. Lower the rho, lower the resistance. The bigger the rho, the bigger the resistance. Okay. So this is the formula actually. Resistance is equal to rho times length over cross-sectional area. The only thing that is not included here is resistivity. Sorry. The only thing not included here is temperature. If you want to put temperature into this formula, can or not? Can. So the complete formula, resistance is equal to rho, because it's directly proportional, length directly proportional over what? Temperature. Temperature is what? The greater the temperature, the greater the resistance. I also put up there. PLT over area. PLT over area. If I were to include temperature. This is the big formula. Not your syllabus. Your syllabus don't put like that. I don't think your syllabus put like that. This is what people learn now. 4 factors. Okay, the final formula for resistance. Okay, Ken. Yours only. Okay, R equals to rho length area. So this part, how to do? Substitute only. Okay, substitute please. Substitute whatever is inside. Okay, they give you. Okay, next one. Constantin wire experiment. So I believe you all know what I'm talking about. How many of you have done the Constantin wire experiment in school? This one is, if I'm not mistaken, last year, SPM 2021, first time, practical exam, resistance of wire. So that means what? You got no chance, because you are SPM 2022. So no chance for you to do this experiment. Okay, just so you need to know. The one with the Constantin wire. You all know what's going on? How many of you done in school? Never do. Teacher never teach. Teacher never teach. Teach too little. Teach too less. Kurang ajar. Okay? So this is looking at what? Looking at length. I will teach you this one next week, because you need to look at the graph. Graph will tell you. Okay? Graph will tell you the relationship. But it's basically you adjust the clip. You call it a jockey. You control the jockey, and then you will see that the longer the wire is, the higher the reading of the resistance. Of course, you need to calculate lah. Okay, based on the V and A. On the graph, you will see you put that V and A.